Alright, hello, this is going to be Solidworks CSWA practice problem 7.7. And if you want to follow along with the video, make sure to follow the link in the description, which will take you to the official Solidworks practice problem database. So let's get started. First of all, let's make our base revolve feature in the front plane. So you'll need your axis of revolution. And I think I'm going to start on the outer profile. Or should it be inner? Inner or outer? I think I'll start inner actually. I'm going to start inner profile. Well, actually no. In the section A view, it seems that the origin is horizontally aligned with the outer profile first. So I guess that's what I'll be doing. Okay. So I'm gonna start from top, go to the bottom here, and then I'm gonna make an arc like this. Like this into a horizontal line like this. It's tangent on both sides, the arc. And let's dimension that arc as being radius 2, because this is the outer profile. And then I guess we'll just immediately do it offsets. So let's go offset entities. So offset this by 1. Yes, offset it by 1. So this outer is going to be outer profile is horizontally coincident with the origin, but then the inner profile is not horizontally coincident with the origin. So this should be correct. And we'll cap it with lines. And select OK. And then we can add the dimension. The dimension from the very bottom of the part to the very top is going to be 12. That vertical is going to be 12, like so. Then this bottom radius right here is going to be R3, which we already know. And then the diameter of the inner circle of the cylinder is going to be 8 in diameter. So we know that the distance between this inner wall and the center line has to be 4. But if I hold it, I can show what the actual diameter is going to be. So I'll click 8 instead. 8. And then we know that the total diameter of the entire base part is 25. So we know that the diameter of the distance from this to its opposite side on the left of the center line is going to be 25. So I'm going to click this, hold the center line, pull it down, and this should be 25. So there's your fully defined base profile. So now we're going to revolve this. So let's go feature, revolve plus base. So there's your revolve parts. Now let's start making our blades. So I'm gonna start sketching the top plane. Actually, maybe I should start the sketch in no, I'm gonna start in the top plane. Like this. And then I'm going to make some cuts. I guess we'll get a corner rectangle here. Let's arbitrarily make it like this. So the horizontal dimension from origin to left side is going to be 9. The vertical dimension distance from origin to its bottom side is going to be 3. 3. Yes. It still seems to be not constrained though. Well, I guess this part doesn't really matter because the only thing that matters is that we're cutting away this portion of the circle. So I guess we'll just give it an arbitrary dimension. So we'll just give this like 6. And then we'll give this like, I don't know, 6 as well. 6 by 6. So 9, 3, 6 by 6. So I think we'll just do an extrude cut there. Just through all both. Select OK. So there's your initial cut. And then let's make our, and then also this cut that we just made, we're going to do a circular pattern of that so we can have that cut for all 4 blades, but we'll do that with the blades at the same time. For now, I'm going to make the blade. So let's start a sketch on this face right here, this face. Okay. Also, yeah, realize from this view that this is where we're going to be drawing our blade, not this. This is just the circular arc of the base part, as you can see. So ignore this and only use this grayish area. So let's see, which way is the blade pointing? The blade is pointing, the blade is always pointing away. So we're gonna start our line here. So we're gonna go to a straight line like this. I don't know how long this is supposed to be. I think it's supposed to be, it should be 8, about 8. So I'm gonna start here. And then I'm gonna make an arc. Oh, not like that. Not like this. Like this. More or less. So I'm gonna make a coincident with this corner right here. And then I'm going to draw a line down, and I'm going to close out the contour. Now the reason this arc is bulging out like this is because its center point of the arc is dictating its behavior. So we need to get rid of that center point, which was like automatically put there, and now we can freely move it without having to worry about it bulging like this. And to make it into its blade pattern, we're going to add a tangent relation between this and the vertical line. Tangent. Now we got our blade. And the only thing left to do from here is to dimension its height. The distance from the tip of the blade to the top face of this base part is going to be 9. Should be like that. I'll go back to the view. So should be looking like this. And that should be your whole blade. Yes, that should be your whole blade. And then it's going to be extruded by 1 millimeter to this side, not inwards, but outwards. So we're gonna go to features, extrude by space. We'll blind extrude it by 1 millimeter, like this. And we'll select OK. So now you've got your rectangular cut along with its extruded blade. So we're going to just simply circular pattern this along with the cut. So I'm going to go to features, linear pattern, circular pattern, and for number of instances I'm going to replace it with 4. Let's make sure it's equal spacing, and then for my features I'm going to click the cut, and then I'm going to click the extrude. And as far as the direction, I'm just going to select this revolve, and it's going to, but by selecting the revolve, it's going to automatically select the center line that I drew as my axis of revolution as the axis of revolution for, or as the axis of, as a pattern axis for my circular pattern. So 4 instances equally spaced, and select the revolve as your reference. So click check, and now it made 4 blades and 4 cuts, and that should be your whole part. So let's check our answer. Let's go to evaluate, mass properties, and for your answer you should be getting 771 cubic millimeters for your volume. 771 cubic millimeters for your volume. So I hope you learned something from this video, and I'll see you in the next one.